This time we are going to round the numbers to 3 significant digits. Many students get confused about it, but you're supposed to realize that these problems are going to get simple if you are going to convert them to scientific notation or engineering notation first. Because in this section we talk about the engineering notation, we are going to convert all of them to the engineering notation and we are going to find the 3 significant figures. Remember, anytime we talk about the engineering notation, we're supposed to make sure that the number on the left side of the decimal point is supposed to be between 1 and 999. In this case, my decimal point is at the end of the number. I do not have power of 10, that's why I have to write always times 10 to 0. Anytime you have no power of 10, you're supposed to write times 10 to 0. And I'm supposed to make sure that the number on the left side is going to be between 1 and 999. Right now I have 70,000, it's too much, okay? That's why I have to move my decimal point 3 times to left. Why 3 times to left? Because I'm supposed to have exponent over here 0 or multiple of 3. 0 doesn't work because I have 70,000, so I have to make this multiple of 3. That's why I have to move my decimal point 3 times to the left. My number gets smaller, exponent has to get bigger. That's why I'm going to have 70.932 times 10 to the third. We said this number has to be round to the 3 significant figures. The 3 significant figures are 1, 2, 3. This is my rounding position, and I'm supposed to check what number is behind of it. If the number behind of my rounding position is less than 5, I'm supposed to write my answer like 70.9 times 10 to the third. And this is the solution to my problem. Let's take a look at this second example. Now I have number 345.7. I'm supposed to round this number to the 3 significant digits. Now the number on the left side of the decimal point is between 1 and 999. So my invisible power of 10 is 10 to 0. Because this number is already between 1 and 999, I'm not going to write times 10 to 0. Simply, I'm going to write just 3 significant figures. 3, 4, 5. And I'm supposed to check what is behind my third significant figure. I have 7. Anytime I have number 5 or greater than 5 behind the rounding position, this is my rounding position, I'm supposed to add 1 to this underlying number. That's why I'm going to have 346. And this is the answer to my problem. Let's take a look at the third example. I have 15.76. Because the number on the left side of the decimal point is between 1 and 999, and I do not have power of 10, I don't supposed to write anything over here in the place of power of 10. Simply count the significant figures. I have 1, 2, 3. Next, you're supposed to check what number is behind your rounding position. Is 6. 6 is greater than 5. That's why you're supposed to add 1 to the rounding position. And your answer is going to look like this. 5.8. You're supposed to add 1 because I have 6 behind 7. And this is the solution to the problem.